So let me start by just listing the 4 services. Some of them Andy talked about at the keynote. Relational databases are used a lot, so we have an aptly, creatively named service called Amazon Relational Database Service, or RDS. We have a service for all the folks who don't want to use relational, so it's called the NoSQL database, which is DynamoDB. And then, of course, we have our petabyte scale data warehouse, which is Redshift. That's been out there since early 2013. It was the service we announced at our first reInvent in this time, 2012. And then finally, our caching service, which is ElastiCache. So if you think about this, you'd wonder, why do we have 4 services? And if you look at old-style technology vendors, like IBM and others, they've been doing this for 30 plus years, as Anurag was mentioning, and they really have only one database. So if you use a database from IBM, it's called DB2. So they have one service. They've been doing it for 40 years. And we have 4 services. So why is it that we're thinking about this in a different way? So the reason is that we think that one size doesn't fit all. Today, in a connected social mobile world where there is a tremendous amount of data being generated, especially with Internet of Things and devices that are connected, it's just not possible to use one database for all use cases. It really makes you like a jack of all trades, a master of none. Whereas I think it's better to give you a solution that's optimized for your use case. So try to give you the best tool for the job that you have at hand. And we'll go into these 4 services and where you should use which one to some extent. So how do we think about these services, and why did we do 4 and not 10? So when we build new services, as you've heard about Amazon, and if you've been using AWS, everything at Amazon really starts with a customer. So we start with a customer and work backwards. In fact, when I came to Amazon 5 years ago, before that, at other companies that I had worked, when you were designing a new product, you developed a product requirement document, which was your rendition of what it is that the product was going to do. At Amazon, we don't do that. The first thing we do when we come up with a new idea is we write a press release, which puts us in the mindset of thinking about the customer and what it is that we're going to share with the customer when the product is all done, which in the case of Aurora was a 3+ year exercise, and here we are today with a press release. So that was the press release we wrote over 3 years ago, saying, okay, if we got all done, what is it that we're going to say to the customer? And the 2 key questions we ask when we try to get to yes in our decision making at the leadership level is, okay, what is it that you're going to enable for customers that they couldn't do before? Because as you know, Amazon is not only customer obsessed, it's also a very inventive company. So when we're doing invention, we want to make sure that we're solving new problems. And the second question we ask is, okay, to the extent that the things that you're going to enable are being done in some form in some of the products, in what way are you making the customer's life better? Are you making it cheaper? Are you making it simpler? Are you making it better? So those are the 2 questions that we ask when we think of a new service. And by and large, what is unique about Amazon and certainly AWS is that when you take one of these ideas as, let's say, an engineer on the team, and you go see Andy Jassy, who's the senior vice president of the business and the CEO of AWS, or other leaders on his team, we try to get to yes as an answer. We try not to find poke holes as a management team and say, well, that's a dumb idea and we should really stop you from doing it. We try and get to problem solving and try and get to a yes. And a lot of the things we do really get to the market. And that's one of the ways we think about it. And as I go through all of the services and I give you a little bit behind the scenes strategy, try to answer these questions in the context of those services. So let me start with our first service, Amazon RDS, which was launched in October of 2009. Initially, it came out with just MySQL. That was the first engine we supported, and then we've added Oracle, SQL Server, Postgres, and of course, this morning we announced the new dawn of databases, relational databases, Aurora. And this is a fully managed service. So why did we do this service? The obvious answer is, duh. For the last 30 years, every application has used relational databases. It makes sense to have a service. And of course, even in the future, many applications will continue to need relational databases, so it makes sense. But then if you think a little harder about it and say, well, I could always do these things on EC2 because EC2 is a our compute platform, you can run any application, you can run any code on it, so certainly you could run databases, and that's where the world has been. And in fact, all the people who have created databases but don't use them feel, which is pretty much all other vendors, they feel that that's good enough because it's just like any other piece of code that you run on a compute platform. But what is unique about Amazon is since the company was startup in July, I guess, of 1995, which is going back many years now, almost 19 years, we have been running databases. We don't only create databases, we actually run them. And our e-commerce business, which is a very large business, as all of you know, is a set of applications that use lots and lots of relational databases. And what we learned in all the years of running these databases is they're really hard. The pain to manage, and if you are involved in the IT industry, you know that one of the leading causes for you losing sleep and getting called late at night when you were trying to get some sleep is because some database, some relational database fails somewhere. It's a leading cause of lost sleep and downtime in the IT world. So we said, okay, yes, you could run relational databases on EC2, but could we do a better job where people get a little more sleep, have a little less downtime, and don't have to deal with all the hassles of management with databases? And that was a core insight that we had, because of which we built Amazon RDS, and we built it from the ground up as a managed service. And what we've been able to do is all the muck associated with configuring databases, starting them, launching them, all of that, we've made that push button easy. You can go to a console, or you can use an API call or a command line interface, and you can say, hey, magically give me an Oracle database. And a few minutes later, you have a fully optimized, configured database that should work for your use cases. And we do all the other things, like we do the patching, we manage the security, we back up all your data so that, in case of failure of some kind, your data is available on S3 to restore from. And we do general care and feeding of databases. And what it does for you is it reduces really the total cost of ownership. In the folks that manage databases, think in terms of DBAs, number of databases that DBAs can manage. And I think when I was talking to the guys at Amazon who've been doing this for a long time, I guess we're relatively speaking pretty good at it. And we manage like 40 databases per DBA. And that gets to be pretty expensive pretty quickly. So one of the things that Amazon RDS does for you is it reduces the total cost of ownership. And in this way, it makes it cheaper, makes it better, and generally meets the second tenet that I talked about when we think of new services where we're making things better. But in case of RDS, we've gone further than that, and we have this whole thing about built-in high availability and cross-region replication. It's a feature that we call Amazon RDS Multi-AZ, which allows you to provide much higher availability than you can get with a single instance database. And in fact, this is something that maybe as a large company, you have the wherewithal to do it, especially if you're using a commercial database where they have things like DataGuard and Oracle, and SQL Server has mirroring and so on, which will allow you to do it. And if you are a large enough company where you have multiple data centers, you can certainly do it between data centers. But if you're a smaller company, you probably wouldn't be able to do anything like a high availability database without what we've done with Multi-AZ. In fact, if you look at it, what Multi-AZ does is it gives you enterprise-grade high availability. We give you an SLA of 99.95, which means less than 20 minutes of downtime on a monthly basis. And the way we do that is that we have done some features which are not part of stock MySQL. We do synchronous replication. We do it across our availability zones, which are essentially data centers. And we have this amazing amount of technology that we've built over the last 5 years, which monitors all those databases and figures out all of the cases in which there's a failure, detects it, automatically flips you over to a standby database, which is running in a different availability zone or in a fault-isolated separate data center, and gets your application back running on it. So it just quickly does a DNS failover, and your application's up and running. It's roughly between 30 to 60 seconds to fail over. And after that, your application continues to run as long as it does the retry on those failures. And this is something that this is something we introduced in middle of 2010. And since then, it's been used quite a bit. And today, roughly 40% of a fleet is multi-AZ, which is all the production use cases we recommend that you use multi-AZ because in case of any kinds of failures, your application is resilient to them. And we're pretty excited about how well it has been adopted by RDS customers. OK, let me give you a few examples of some customers. I was going to talk about Intuit, but some of you who were at the keynote saw that Intuit is all in on Amazon and AWS, and they have lots of applications. I guess Taylor said they have something like 33 applications and 26 services which are already running on AWS, and over the next few years, they're going to move rest of their applications to AWS. And in fact, they use a lot of relational databases. They use MySQL. They use Oracle. And one of the key reasons that they move to AWS is because of Amazon RDS and the total cost of ownership reduction that it results in for them and the agility that they get from using AWS and using RDS, as well as the high availability that they get with this solution. And there are lots and lots of other customers who are using Amazon RDS. There's some very big companies. Samsung was an example that Andy also mentioned. Their smart TV business runs completely on AWS and uses Amazon RDS with MySQL, Oracle, and a number of other engines. And of course, my favorite as a Democrat, in 2012, Obama's campaign ran on AWS, and I was pretty excited about it. And we helped him get elected, and certainly RDS played a big role in it. And there are other companies like Coursera, which is really exciting. These guys are providing online education, and it's something where they use databases quite a bit and depend on RDS. There are over 10 million users that use their online services. And of course, Intuit is another example. So there are a variety of companies of different shapes and sizes that over the last 5 years have adopted RDS. And it's probably fair to say that Amazon RDS runs one of the largest fleets of relational databases anywhere in the world. And from that experience, we continue to enhance this service. And of course, Andy talked about reinventing the relational database, and I'm going to touch on that a little bit, and we'll leave some time at the end for questions. I'm sure on Twitter and Hacker News, I saw a bunch of questions coming up on what we did with this new dawn of relational databases with Aurora. And I'm going to go into some of the questions that we asked. This is going back now 3 or 4 years when we started thinking about this service. Hey, if we could really design a database for the cloud where we said the cloud is the new normal, as Andy said, and you didn't have to worry about on-premise and worry about the old way of doing things. And you simply took one constraint, and the constraint is, at the end of the day, it's still a relational database. That's the only constraint. Everything else is clean slate. What could you do? Could you provide a database which is amazing in terms of the performance it provides because it has all of the compute capability and the scale of AWS to leverage? Could you provide availability and durability where the durability is indistinguishable from 100%? And of course, you're dealing with relational databases, so we thought we would take a high goal of 99.99% availability, which is 4 minutes of downtime on a monthly basis as a design goal. And said, could we do that? And then, of course, our team went to work on it. And what came out 3 years later is Amazon Aurora, which completely changes the way databases, relational databases have been done over the last 30 years. And it's, as Andy also mentioned, it's significantly cheaper than what you can get from commercial databases. So it's, as I mentioned, it's a database engine which we have built ourselves. It's the only constraint we've taken is that it's compatible with SQL. And in our case, we started with MySQL as the API or as a SQL dialect that we wanted to be compatible with. And we are offering commercial-grade performance and availability at open-source prices. And we retain compatibility with MySQL 5.6, and we will maintain compatibility with newer versions of MySQL as it comes along. But the production-ready version of MySQL that's out there today is 5.6. And let me just quickly highlight some of the things that we mentioned at the keynote where Anurag talked about this. It's 5 times the performance in our benchmarks that we've done. We've used sysbench as the typical benchmark that you use with MySQL. And we're able to do 100,000 writes a second and 500,000 reads a second, which is a very big deal. And you can do up to 15 read replicas connected to a single master. And that means that you can do 8 million reads a second. That's a big deal from the sorts of things that I've seen in the database world. You can take a database and start out with just 10 gigs, which is the smallest database you can start with. And you don't have to say anything to us about how you need to scale it. You don't have to provision a terabyte if you're using 200 gigs and so on. We just grow the database as you need to, and we can grow it up to 64 terabytes in the version that is going into preview. And I checked around at Amazon to say, hey, what are some of the big databases that we have? And some of them are like 12 terabytes because in the databases get pretty big when you're using a data warehouse, but when you're using OLTP, the databases tend to be, the biggest databases tend to be in the 10, 12, 15 terabyte range from what I understand. And we're able to take you to 64 terabytes so that you don't have to worry about the scale aspect of databases, either from a storage perspective or from I/O perspective. If you need to do more than 100,000 writes a second, which some people may want to do, then I'd say we'll give you a different solution. But for that, if you want full MySQL compatibility, Aurora is the way to go. And the way we achieve this is something that Anurag talked about in a little bit of detail. We not only have innovated in the MySQL engine, we've also purpose-built a completely different virtualized storage layer which is designed for database workloads. So essentially what we have done is we've taken the lower half of the database engine, if you will, which tends to do the sorts of things that modern virtualized storage services do, and essentially tightly couple them. So not only have we built a brand new storage service, which is anytime you do a write, it writes to all of the different AZs. It writes to 3 AZs, does 2 copies in every AZ. But it also is tightly coupled with the database engine so that you reduce the number of IOs that one has to do to get the kind of performance we're talking about. In fact, with a typical MySQL application or a typical database, when you do a write, you do a redo log, you do a data page, and a bunch of other writes. So a write gets expanded to something like 6 writes. In our case, we reduce the total number of writes that you have to do to just 2. So that's what gives us, one of the things that gives us the performance improvements and throughput improvements that we're talking about. And since we do 6-way replication in 3 availability zones, and remind you that RDS MySQL, or RDS in general today, multi-AZ, does 2 copies in 2 AZs. In this case, we're going to 3 AZs and 6 copies. And you can have, in case of multi-AZ, your standby does not do any read traffic. It's just a standby, which sits there till there is an issue of some kind, and then it fails over. In this case, your standby is actually a read replica. You can have 15 of those spread across 3 AZs. And if there is a failure of your master database, we'll flip over to a standby read replica if you have one of them. If that fails, we'll go to a second one. We can go through 16 of them, 15 of them, before there's an issue for you. So it gives you a level of availability which is going to be at least as good as commercial databases. I personally believe that as you guys use it in preview, you'll find that it goes way beyond. And all of this without the expensive cost of commercial enterprise-grade databases where not only you have to pay for those commercial-grade databases, their enterprise version of it, but then if you want to get high availability, you have to buy the high availability option. None of that here. You just start out at a price point as low as 29 cents. It's like, a little more than a quarter. If you're going to buy a cup of coffee this morning, you could probably buy yourself a dozen of these for an hour and just spin them up. So it's pretty inexpensive and pretty powerful. We're super excited about what the team has done over the last 3-4 years as we have built this. Okay, so who should use RDS Aurora? Because Aurora is an engine, it's part of RDS. And our view is that if you are a MySQL user, you should use Aurora. It's going to be going into preview, so if you're running production applications, of course, those you would run till we are in preview on MySQL Stock Edition, which is Community Edition. But after that, you should be able to move all of those applications to Aurora. And if you're designing a new application and you want the commercial grade performance and availability, you should use Aurora. All right, so that's about relational databases and RDS and how we think about those and how over the last 5 years we've come from starting with a service that started as MySQL and then taking it all the way to reinventing the database. Let me talk a little bit about our NoSQL service, which is DynamoDB. It's a fast, flexible, scalable NoSQL service, fully managed, and give you a little bit of an insight as to how we thought about it. Let me start with a little bit of a history of NoSQL at Amazon. I guess the way the story goes is that, and I wasn't here at the time at Amazon, but in 2004, in our busy Christmas season, where we make a lot of our money as a retailer in the e-commerce space, our databases, which were running on Oracle RAC, I believe, decided to go down. And we had an outage for, I think, number of hours, and we lost millions of dollars. And after that, Jeff called Werner, who's our CTO, and said, hey, man, you got to have a better database next time around. You got a year to figure this out because Christmas is going to come around next year, and I don't want to have this issue. So he went to work with a number of people that are, that were part of his team, Swami and a bunch of other folks. And they came up with a new kind of technology, which really, in some ways, is the start of the NoSQL segment or movement in terms of building highly scalable, highly available databases. And the issue we were having was we were running our business in 2004 at a scale that relational databases just couldn't scale to, and they couldn't give you the kind of availability that we needed for our business. And they wrote a very famous paper based on the research that we did in 2004 and 5, which is something that all distributed systems engineers read. It's a Dynamo paper. And that really laid out many of the concepts that have become the basis for a lot of the NoSQL stores. Cassandra is based on it. There are many other products in the market which are open source products that are based on those concepts. And we took the same concepts when we started to build DynamoDB. We launched DynamoDB in January of 2012. So it was a multi-year effort prior to that. And again, in terms of the quick key questions we asked was, well, we were thinking about doing Aurora at the time. And said, OK, in Aurora, we're taking a constraint, which is called SQL. So we're going to say yes to SQL for Aurora. What if we say no to SQL, which is take no constraints at all, complete clean sheet of paper. So NoSQL, no to SQL became NoSQL. And we said, what could we do? Could we eliminate the things that even after an amazing database like Aurora comes out, you're going to say, I wish those constraints were not there? Could we make it better in ways that relational could never do? And what we have been able to do to DynamoDB is that we give you a scale, seamless scale, beyond where a single box can scale. So in case of Aurora, if you don't want to shard, and sharding is not transparent to the application, you can go up to R38XL, which is the largest instance we can give you. And on that one, you can do 100,000 writes and 500,000 reads. Certainly, you can scale reads using read replicas, but writes without sharding, you have no choice. We have customers who do way more than 100,000 writes a second. There are applications that need that. We have one customer that does close to 1 million writes a second. That's the kind of database they need. So we felt that for something like that, DynamoDB is the answer, because what DynamoDB does is, because it doesn't have the constraint of SQL and relational semantics, it's able to shard your data and your tables behind the scenes and give you as much I/O as you want. So all you do is, it's completely schema-less. All you do is you start out and give us a table, create a table, and you start writing to it. And you can start out by saying, I want 10 writes and 10 reads, because I'm just testing my application. And when it comes day to launch, you can dial that up to 1 million reads and writes, and we'll just keep on chugging. And the other thing that is unique about DynamoDB, which is hard to do with relational, is the predictable performance. There are many of us who deal with relational databases, and it's running really well. And in the morning, when you come in, you find that there's some kind of hiccup. Your queries are running slow because there's more data in the system. There's something that happened, and your query optimizer decided it's going to do some kind of cost-based optimization, which it didn't quite do it the way It should, and your queries are running slow, and you're running around trying to figure out why are my queries running slow, and diagnosing why application is coming down. And none of this happens with DynamoDB because we give you predictable performance and latencies which are in the single-digit milliseconds. And we just, no matter how many IOs you want, how many users are using your application, your database continues to give you the same kind of a performance. And it does all of this along with giving you availability which is indistinguishable from 100%. So this database gives you more than 99.99% availability, and there's no notion of failovers. So there's not this issue which happens with the relational databases that in case of a failover, it takes you 30 to 60 minutes to fail over your application from a master to a slave, which becomes a new master. In this case, this is completely transparent. So these are some of the things that we are able to do because we removed the constraint of relational semantics. And as I mentioned, there's nothing to manage. There's not even a notion of an instance. It's just a multi-tenant service. You just create a table, and you just keep writing to it. And the table doesn't have a schema, so you can have items or rows with whatever you want in them. And with the latest release of DynamoDB, we are not only a key value store, which is what it started out in early 2012 when we launched it. It's become both a key value store and a document store. It supports JSON objects natively, and it does queries against not only the primary key, but also against your secondary keys. So you can have secondary indices, and you can do queries against all of them, which at scale is a fairly hard problem. So it took us 2 more years since we launched the original product to make that available in early 2014. So let me talk a little bit about the latency that I mentioned. Here's a graph from our fleet. As the number of requests go up and down, the average latency is flat. It gives you the same read latency and same write latency, no matter what you're doing with your database and how many IOs you need and what other customers are doing. And we have customers, and I will go through some of them, who use this in a very interesting way. And here's one of my favorite customers. And this is a company that is a startup which was started by Ray Ozzie. Many of you probably know Ray. He's the guy who started Lotus Notes back in the days. And he was the chief technology officer at Microsoft when he started, after retiring from Microsoft, when he started his company, he built it on DynamoDB and AWS. And it's really exciting to see customers when they love your product. And these guys, for 2 years, have had 100% uptime. They don't spend any time scaling their database, and it just is available for them all the time. And we have many customers like that. In fact, AdRoll is another customer like this that is in the ad exchange business. They run 120 billion requests a day. They need very tight latencies because in the business they have something like 20 to 25 milliseconds to bid on an ad, and they need to have a database that can respond to queries quickly with a predictable under 10 millisecond kind of a read latency, always the same kind of read latency, so they can bid on their ads. And these guys have looked at, and before they came to DynamoDB, they had tried Mongo, they tried Cassandra, they tried every other NoSQL store, and it just wasn't scaling to their needs. It wasn't providing the kind of availability and performance that they needed, and they switched to DynamoDB over 2 years ago and have been delighted with it ever since. And we have a bunch of other delighted customers. In fact, one of the things that I'm happy to share, and this is something that you might have already heard about from James Hamilton. We last year when we came to reInvent, we talked about 2.2 trillion operations, which is a massive number in just one of our regions. We have 11 regions today. In one of the regions, we were doing 2.2 million IOs, reads and writes a month. We're now doing over 7 trillion. So over a 3x increase in the IO that applications who have adopted DynamoDB do over the last 12 months. And the number of storage is even higher. Amount of storage being used in DynamoDB is even higher than 3x over the last year or so. And here are some of the customers that are using it. Dropcam, which is now a Google company, uses it. SmugMug, which is a photo sharing and photo storage site, uses it. Enterprise customers like News International that are moving I guess Andy said this morning they're coming down from something like 60 data centers down to 6, if I get my numbers correct. And many other companies. And the one that I would highlight quickly is a company called Shazam, which is a UK-based startup, or used to be a startup. It's probably a much bigger company now. And they use our service in a very interesting way. In fact, one of the use cases that we have talked about is where they do these Shazamable ads at Super Bowl, and they need massive scale for the few hours when Super Bowl is on. And these guys use, I think something like 500,000 reads and writes a second for those 4 hours, and then they dial it down. I don't know anywhere else that you could have a massive database like that just for 4 hours. And there are many other online voting applications that work with reality shows that we all love at prime time at night that are all based on DynamoDB as the data store behind it. Okay, let me quickly go into some other services, 2 more. I have a few more minutes to walk you through these. ElastiCache is a caching service that started out as a memcached service and now supports Redis. It's fully managed. And in this case, it was a pretty simple decision to do it because Amazon RDS had been out there and many people that were using it were benefiting from the fact that we were managing all the muck and they were getting all the benefits of total cost of ownership being lower because we do all the management, and they asked for the same thing. And we felt that, because humans read more than they write, pretty much read is more important for databases in today's world. I think it's going to change with Internet of Things where people are going to write more than they'll read because machines write more than they read. But in the human world, reading is more important, and therefore caching is critical for all databases. And we felt that just like we had done for RDS, it would make sense for us to do in-memory caching service that was fully managed. And it's been very well adopted. We started out with memcached. And last year in September, we launched Redis, which has been pretty amazing in terms of the growth we've seen with it as well. And we most recently launched a multi-easy feature for it so that not only can you have read replicas for your master caching server, but it can also be used to flip over in case of a failure, just like we do with RDS. And the service has done really well for us. It's being used by some of our very large customers. Expedia uses it. Gumi is a gaming company in Japan that uses it. Guri is a gaming platform in Japan that uses it. And many, many other companies like Airbnb, which is an amazing startup. And finally, let me take a few minutes to talk about Amazon Redshift, which is our petabyte scale data warehouse. This is something we launched in February of 2013 for production use case. It's been something that was available in preview starting at reInvent, our very first reInvent in 2012. So it's been available for production use case for about 20 months. I'm going to go into all the details with it, and it's one of our fastest growing services. And there are a number of people that are using it, super excited about it, both in terms of what customers are doing and how well it's growing. And when we built it, we launched it in early 2013. It was, again, a multi-year effort for us. We said, what's the reason for building a data warehouse like Redshift? And the thing that was really interesting at that time was that we had a customer, was a pretty big customer of ours, and they were generating terabytes of data, tens of terabytes of data every day. And they had no way of analyzing it because there was no data warehouse available. And they were taking it from the cloud back to on-premise, and they were running one of those old data warehouses, expensive data warehouses, analyzing it, and then bringing the results back to their application running on AWS. And we thought that was kind of backwards. It makes no sense to have the data be born in the cloud and then have to go to the on-premise just because such a service wasn't available. And then we had many other customers, one of them who said, look, I've moved everything to AWS. I'm 100% in. I just have one service running on-premise, which is my data warehouse, and I can't shut down my data center till you give me a service like that. And to us, that was a good enough reason to do it. And then when we said, OK, we're going to do something in this space, then we asked the 2 questions that I highlighted initially. What are you going to do that people couldn't do before? And how are you going to make people's lives better? And here's the key insight that drove this for us. So the key insight was that today there's a lot of data being generated. If you look at any company, only roughly 10% of the data that they have access to is being analyzed. The rest of it is literally being thrown on the floor because is just too hard to build a data warehouse that could be at a scale to analyze 100% of your data. And could be at a cost where you could justify to your boss that, hey, this data that I have really has an ROI on it for me to really use it. So we said, well, could we build a service where you didn't have to think about the complexity as being an issue or the cost being an issue, so that if you had data which had some value to you, you could use it. And that's where that was really the key design point for us in terms of what we did. And we said, we will leverage the massive scale of the cloud to give you something that was so scalable and so cheap that you could analyze all your data. And what we ended up building, which was a multi-year exercise because this is a complicated data warehousing system behind the scenes, is that we decided to build what is known in the industry as an MPP system, massively parallel processing architecture, where you can take a system which starts out with a single database node and scale it up. Today we can scale it up to 128 nodes. And this is all behind the scenes. It's completely transparent to your application. To the application, it just looks like a Postgres compatible SQL endpoint, and behind the scenes it scales. And so that we could give you the massive scalability that you could do. And you can do a single cluster with 2 petabytes of data. And this is something where we built it as a column store instead of traditional data warehouses, which historically have been built as row stores, because queries happen across a column. So if you store your data in the column major format, you're able to reduce the number of IOs it takes you to do the query, which increase the performance. And the way we priced it is at $1,000 a terabyte. So those of you who are familiar with data warehouses know that the cheapest data warehouses usually run $10,000 a terabyte. And there are systems like Teradata and others, Oracle and others, that can be as expensive as $50,000 a terabyte per year. So it's a tenth the cost of an average data warehouse that you could buy before we came out, and it's 10x the performance because of the scalability and the performance with column stores and MPP that we give you. And you can, if you want a data warehouse which has a petabyte of data that it can store, it takes 3 minutes to set that up. Instead of a year, it'll take you to, in the old way, to write the justification and come up with the millions of dollars it takes you, then do a prototype and a pilot for 6 months and say it kind of sort of works, and I'm willing to spend the millions of dollars. Here it just, if you can afford a cup of coffee, this is kind of the benchmark for me, you can use our service, and you can use it at scale. In fact, we even have a trial you can get, which gets you going right away. And it's fully managed. We do all that. This is true for all of our services. Fully managed. We all the provisioning in 3 minutes in this case. And we all do all the patching, security, backups. And in case of a data warehouse, backup is a very hard, interesting problem, because when you have, a 2 petabyte data warehouse, how do you back it up? Because it's going to take you a while. So what we do is, in our case, we do a continuous backup, continuous incremental backup to S3. And we're able to build, in case there are failures of nodes, we build them from each other because we maintain enough data on these data warehouse clusters that you don't even have to go to S3 to restore the data. So very innovative service. Here's some of the architecture that I've already spoken about, so I'm not going to go into too much detail. The only thing I'd highlight is that it comes in 2 flavors. There is a data warehouse node, which was our original node that we call DWM. It's a very creative name. It starts out, it's a magnetic storage instance with local store, which is magnetic. It starts out at 2 terabytes as a smaller instance, or a larger instance, which is at 16 terabytes. You can scale this with 16 terabytes up to 128 nodes to get to roughly 2 petabytes of space. There's also a newer instance that is based on SSDs, which starts out at 25 cents an hour in on-demand pricing, and starts out with 160 gigs, and you can take it all the way up to 256 terabytes of space with 100 nodes. And here's an example of NTT, which is one of our customers that uses it. This is the one that Andy mentioned in the keynote as someone that uses our data warehouse as a 4 petabyte in the cloud data warehouse. And in their case, the data actually starts out on premise, and they have a number of simultaneous direct connects. They have 10 gig direct connects that they do from their data center to ours to move terabytes of data that gets generated every day into the cloud to make sure it's current and is able to do all the queries and all the analysis that's needed. And here are some of the customers. NASDAQ is a great example of a customer. Nokia is another one. Salesforce uses it. There are lots of earlier stage companies, fast-growing startups. Pinterest is another one that uses this. Nintendo. A lot of companies. This is becoming the default way that you ought to do a data warehouse. And here's, in case of data warehouses, you also need other tools that go with it. So for example, you have to use your favorite BI tool because everybody wants their own dashboards and so on. There are a number of companies that are in that business. Tableau is a great partner of ours. MicroStrategy is another one. We pretty much work with all of the partners from both the ETL side, like Informatica and Attunity and other players, and BI side, folks like Tableau, to give you a complete solution. So we're basically changing the game in databases, and the pace of innovation, as this is something that Andy talked about across all of AWS. I'm talking about it in terms of databases. Here are the number of things we've done. We launched RDS in 2009. We added multi-AZ to it in 2010. We launched with Oracle in 2011. We also launched ElastiCache in 2011. In 2012, we had DynamoDB as the major service we launched. We launched SQL Server support for RDS. In 2013, we did Redshift and a number of other things such as Redis support. And there are lots and lots of features that have been continuously built over this. So there's a massive amount of investment and innovation that is going into these services to make them better all the time. And as I said, in summary, in a connected world, data volume is growing, and you got to have a solution that gives you a response time that makes sense, which is certainly, everything has to be faster every day. And we think that in this world, one size doesn't fit all, which is why we've done multiple services, and each service there are flavors that we give you, because at the end of the day, it's the customer and what they want, which drives our innovation. And just to summarize it at the end, if you have a database that you need to use, here's sort of the way that I think about which database to use from a portfolio of services. If you're writing an existing application, you probably have a database that you're used to. In the old days, a company would be will focus on a single database, like a company would be a SQL Server shop or an IBM shop or Oracle shop, because you had to manage the database, so you had to kind of know the guts of how that was done. Of course, in our world, because you don't manage the database, it just becomes a variant of SQL. And so if you have an existing application, it probably has a database it uses. If it's Oracle or SQL Server or Postgres, you use the respective version of RDS. It's a no-brainer. If you're using MySQL, we think that you're going to be most happy with RDS for Aurora once it comes out of preview, and you should try it during preview to see how you like it. And if you're building a new application, our recommendation is that you look at your application and see if you can denormalize the data and get away from using the relational semantics. If your application can support it, if you can do without joins, and so on, you will build an application that will have scale built into it whenever you need it. So you don't have to worry about, oh my gosh, what happens if my app becomes very successful? Do I have to shard at that point? Certainly, we have taken the bar, moved it up with Aurora, but if you have an application which can be, where the data can be denormalized and your application can do without the relational semantics, you will have the highest scale, most predictable performance, highest availability, and the cheapest cost with DynamoDB. And if you need relational, you go to Aurora. And if you need a data warehouse, obviously the place to go is Redshift. All right. So we will manage the muck for you so that you can focus on your application. And with that, I'll end my presentation 7 seconds earlier. If you guys have questions, I'm going to be around for a few more minutes. Thank you.